Hello everyone, welcome to the Waveshare ESP32 Arduino Getting Started tutorial series. I'm Wulu from the Waveshare team, and I'm delighted to join you in exploring the amazing world of ESP32. In this series, we aim to guide you step by step into the world of ESP32 in an easy-to-understand way, helping you quickly get started with development. Our goal is to empower you to turn your ideas into reality. Now, before we officially begin, let's open our minds. When we talk about turning ideas into reality, what exactly can ESP32 do? The application scope of ESP32 is actually very broad, covering almost every aspect of our lives. In the field of smart home, you can create a smart desk lamp that senses ambient light and automatically adjusts brightness, a smart socket that can be controlled remotely via a mobile app, or even an environmental butler that monitors temperature and humidity at home in real time. In industrial automation scenarios, you can use it to remotely control equipment, collect production line data, and monitor device status via the cloud at any time. For wearable devices, you can DIY a smart bracelet that records heart rate and steps, or a Pixel watch that can receive mobile notifications. In the vast world of the Internet of Things, you can deploy environmental monitoring stations, smart agricultural sensor networks, and achieve interconnection of all things. In robotics, from simple automatic obstacle-avoiding cars to complex robots requiring network remote control, ESP32 can serve as the control core. Of course, there are also countless creative projects, such as cool LED light art installations, networked music players, retro game consoles, and so on. It can be said that as long as you have creativity, ESP32 can become the tool in your hands to turn ideas into reality. So, why can ESP32 achieve so many functions? This brings us to its core features. First, let's get to know ESP32. Simply put, ESP32 is a series of powerful system-on-chip devices, commonly known as SoCs, developed by a company called Espressif systems. Its biggest features are high cost-effectiveness and low power consumption. On a chip the size of a fingernail, it simultaneously integrates the two most commonly used wireless communication functions, Wi-Fi and Bluetooth. This means that any device you build with it can easily connect to the internet or your phone. After years of development, ESP32 has grown into a large product family. What we now refer to as ESP32 usually no longer refers to a single initial model, but to the entire ESP32 chip family. To meet different application scenarios, Espressif has launched series models with distinct characteristics. Let's look at a table to quickly get acquainted with some representative family members. You only need a general impression. While there are many models with various features, the best part is, the vast majority of them can be developed using the same set of software tools. This means the knowledge you acquire and the code you write can be easily reused and ported between different chips, greatly improving development efficiency. So, how do we develop ESP32? There are various ESP32 development boards on the market. Their core functions are similar but differ in size, pins, and onboard resources to meet different project needs. In this tutorial series, we will use this ESP32 S3 Zero Mini development board designed by Waveshare Electronics. It is based on the powerful ESP32 S3 chip, offering not only excellent performance, but also a very compact size and rich onboard interfaces. Whether you are a beginner or an experienced player, it is an excellent tool for getting started and creating. Of course, as I mentioned earlier, ESP32 code has good portability. You can also use other ESP32 development boards to follow this tutorial. However, to ensure a consistent learning experience, it is recommended to use a development board based on the ESP32 S3 chip. After preparing the development board, we also need to write programs to control it. ESP32 has a very rich development ecosystem, supporting multiple programming methods. ESP-IDF Framework. This is the professional development framework officially provided by Espressif, based on the C++ language. It can fully leverage all the performance and functions of ESP32, providing the most low-level control and highest operational efficiency. It is the preferred solution for professional development and commercial products. MicroPython. If you are familiar with Python, MicroPython allows you to quickly implement various functions on ESP32 using concise and elegant Python syntax. It is ideal for rapid prototyping and teaching. Arduino platform. Based on C++ language, it provides a set of simple programming interfaces and rich library resources. Its huge community support and vast number of example codes make it an ideal choice for beginners. Other platforms. The ESP32 development ecosystem is extremely rich, also supporting various development platforms such as Platform.io, ESP Home, Arduino, meeting the needs of developers with different technical backgrounds. Each method has its unique advantages. In this Getting Started tutorial series, we choose the Arduino platform as our starting point for learning because it strikes a balance between powerful functionality and ease of use, making it very suitable for beginners. To develop ESP32 using the Arduino method, we need a core tool. The Arduino IDE is an open-source integrated development environment. It was initially designed for Arduino's own development boards, but its open architecture allows third-party hardware manufacturers to adapt it. Espressif has officially provided us with a core support package called Arduino ESP32, allowing our ESP32 development boards to be perfectly recognized and programmed in Arduino IDE. As you can see, it already supports the vast majority of mainstream ESP32 chips. Arduino has a rich ecosystem, and many developers in the community have used Arduino IDE and ESP32 to develop many interesting creative projects. It is suitable for beginners to get started quickly and for experienced developers to perform rapid prototyping. Now, let's get hands-on and install and configure our development environment. Open your browser, enter arduino.cc in the address bar to go to the Arduino website. At the top of the site, find Products, then under Software, find Arduino IDE to enter the download page. Choose the appropriate version for your operating system. Here, we use Windows as an example. Click to download. After the download is complete, run the installer. During the installation, it is recommended to keep the default settings. However, the most important point is that the installation path is recommended to be a pure English path without any special characters. Otherwise, it may lead to unexpected issues. Start Arduino IDE after installation. On first startup, the IDE may automatically download and install core library files and drivers. If the operating system pops up with driver installation or network security prompts, it is recommended to allow them. Scrolling information appearing in the bottom output window is normal. Wait patiently for it to complete. Arduino IDE defaults to an English interface, but supports language switching. Click File, Preferences to open the settings. In the Settings interface, find the language option, select your preferred language, and then click OK. Arduino IDE will restart and switch to the selected language. Additionally, in Preferences, you can also adjust interface scaling, font size, theme style, and the default save location for projects. Finally, the most crucial step, making Arduino IDE recognize our ESP32 development board. As mentioned before, Arduino IDE was initially designed for Arduino development boards. Therefore, to use it for ESP32 development, we need to manually install the ESP32 board support package. The default ESP32 support version in Arduino IDE often lags. To avoid not finding new model development boards, it is strongly recommended to manually add the official source. Open File Preferences. In the Settings interface, find Additional Boards Manager URLs. Paste the following link and click OK. You can find this link in the video description. Wait for the index loading in the lower right corner to complete. Open Boards Manager, search for ESP32 and install it. If you encounter network issues during installation and it fails, you can click Install again to retry. When you see it display installed, congratulations! Your ESP32 Arduino development environment setup is complete. If you prefer learning from written tutorials, we've published the complete text version of this series on the Waveshare Wiki, along with sample code and related materials. You'll find the documentation link in the video description. We recommend using both the videos and written guides together, as the documentation often contains additional resources not covered in the videos. As for hardware, you can use any ESP32 board you already have, along with your own components, to follow along. If you'd like to skip the hassle of picking parts, we've also prepared a ESP32 S30 Basic Kit, specially designed for this tutorial series. It includes all the core hardware you'll need. The purchase link is also in the description below. All right, that's all for today's content. Let's quickly review what we've learned. Got to know ESP32, a powerful IoT chip, and its vast family. Understood the various programming methods for ESP32 and clarified that this tutorial series will use the Arduino platform. Most importantly, we have personally set up the complete Arduino IDE development environment, paving the way for subsequent programming practice. Finally, if you find any errors, have questions, or suggestions in this tutorial, please feel free to leave a comment. Looking forward to having ESP32 send its first greeting to the world together with you in the next video. Thank you for watching, and see you in the next lesson.